hi guys. We are going to move into sequences and series. So I think you guys are going to appreciate it a little bit more. Okay, a sequence is just a list of numbers. Okay, that's all a sequence is it's just a list and it's got like a pattern to it. Okay, the textbook calls it like consecutive terms or constant. There's a consistency to it, so that you can just see this pattern, this relationship going on. Okay, so arithmetic means that it's a list of numbers that adds or subtracts the same amount. Okay, and same is key there. There's a consistency to it. You're always going to add the same thing, or you're always going to subtract. Okay, so the common difference, that's the mathematical word to decide on. This is the amount that is being added or subtracted. Okay, so we're going to need to know what the difference is in order to recognize, and then a lot of times in order to use the formulas. Okay, geometric is just slightly different in that instead of adding or subtracting, so think of arithmetic, A is adding. Geometric is actually our other operation. So it is a list of numbers. Let me get a different red. A list of numbers that multiplies or divides the same amount. Okay, and by multiply or dividing, that can also include fractions and fractions. Okay, so yeah, I think you can see that. Okay, so the common ratio, so D stands for difference. Okay, that's what we're adding or subtracting. Remember, difference means subtraction. And then ratio, well, ratio is a fraction. So the ratio is the amount that is being multiplied, divided, or it's that fraction. But that fraction is being multiplied or divided. So the key is that is the actual number. That is what, are we doubling it, that kinds of stuff. All right, so then let's look at the list and just decide, is it going up by adding? Is it going up by multiplying, or is it going down by subtracting or division, in order just to recognize the types, okay? So right now we just want to recognize arithmetic compared to geometric, and whether and what the difference is or what the ratio is, okay? So alright, so let's look at these problems. Alright, so let's just look at the numbers. It's a list. This is going up by 9. It's going up by 9. It's going up by 9. So since I just ask, well, what is it being added or subtracted, or what is being multiplied? So I just started with adding or subtracting. And since this is saying plus 9, plus 9, plus 9. Okay? Since that is the pattern, this is arithmetic. And the common difference, which we use the variable d for difference, would be 9, because that's what we are adding. Okay, so that's what it's saying. Is it arithmetic, geometric, and I want us to go ahead and start recognizing the difference or the ratio as well. Okay? All right, number 2. This looks like it's going up by 3, and then it's going up by 5, then it's going up by 7. Okay, and if I try to think of multiply, well, this is multiplied by 4, and then 4 doesn't multiply anything to get 9, so that really doesn't do anything. So because this difference is not the same, this is actually neither. Because we're not multiplying by the same constant thing or adding or subtracting by the same constant thing. Okay? All right, so this one, it's going up by 1, and then this goes up by 2, and then that goes up by 3, and I know that, and that's a little bit hard to see, I know. That goes up by 4. Again, you're multiplying by 2, you're multiplying by 2, but then you're not multiplying. There's no pattern, there's no constant number by adding or multiplying, so that's a neither. Okay, so then we go here. All right, so from 1/2 to negative 1/2, that is much harder to do adding or subtracting. So because we've got a fraction, and because our signs keep changing from positive, negative, this is probably geometric. It's probably multiplying by something. So I believe it looks like we're multiplying by a -2, because that will get you to negative 1/2. And the negative 1/2 times another -2 will give you positive 2. 2 times -2 will get you -4. So we're multiplying by that same constant number. So this is geometric, and the ratio is a -2. This means that we're multiplying by the same constant thing. That is that constant, that -2. Okay? All right. Number 8. You can't multiply anything by 8 to get it down to -9. You could, but it would be a fraction, and it's probably not what we're doing. So let's do subtraction again, and let's say, okay, well, this looks like it's going down by 17, I want to say. Then this looks like it's going down again by 17. This looks like it's going down again by 17. So this is arithmetic. But in this case, it's subtracting. It's going down in value. So the difference is a -17. Okay? Because if it's positive, that means we're adding the number. If it's a negative, that means we were taking that number away. Okay? So this is an example of adding and subtracting. They're both arithmetic. Geometric is multiplying. And then these are neither. We see a pattern, but it actually doesn't... it's not the same exact thing. We need it to be one constant number that is increasing or decreasing our lists, okay? All right, so now before we get into actually using some formulas, it says use the given rule to find the term, okay? Well, this is our rule that we're given, and this just stands for, this is just our general rule. This stands for the number that we want. So for example, it says find a sub 5 if a sub n equals 3n minus 5. Well, this is just a bunch of substitution. If I'm saying a sub 5, that means I take that n out and I put a 5 in. Well, that means that I do the same thing here. It's kind of like functions. I take the n out and I put a 5 in. So then that's 15 minus 7, which is 8. Okay? But it's actually telling you the number of term that you're talking about. So like if I put a 1 in, that'd be the first term. If I put a 2 in, that would be the second term. 3 in would be the third term. So this is the fifth term. When I put a 5 in, that's what I get out. Okay? So a sub 8 means I take out the n and I put in an 8, kind of like a function. So -2 minus 3, take out the n, put in an 8. So that's -2 minus 24, which is -26. Okay? So it's just another type of notation. So it does kind of remind me of functions where you're taking out the variable and you're putting in a number. And that's the rule that we're using in this case. Okay? All right, so let's take a break from that, and then we're going to use our formulas. Yes, we're going to use our formulas. There's some formulas on your sheets that you get for your SOL test to answer the rest of these questions, okay?